Hey there, my name is Dalwei Liu, and I'll be presenting on the first lab of Introductory Physics 2 at Georgia Tech, titled Charge Tapes. This experiment was based off of the question in Matter and Interactions, 4th edition, 2nd volume, titled, Is Invisible Tape Electrically Charged? Shown here is a brief preview of the main results of the lab described in numerical form. The purpose of this experiment was to prepare charged pieces of clear tape, known as U-tapes, and then to determine whether or not these pieces of invisible tape could be charged. We then quantified approximately how much excess charge was in one piece, and then used GlowScript to simulate these behaviors using Web VPython. Shown here are the models and fundamental physical principles employed in this experiment. Newton's second law, Coulomb's law, electric field, gravitational, and electric force were all relevant to this experiment. The equations, specifically Coulomb's law for electrostatic force, could be isolated to solve for a specific quantity such as the charge from an electric field. The relevant physical constants are also shown. This experiment sought to demonstrate that a tape attached by two ends could be made to float when another U-tape was brought near it. Certain assumptions and idealizations, including the point charge being in the center of the tape, negligible air resistance, and other extraneous forces, the net force being equal to 0, and clear tape being about 1 gram per meter, were made to support the calculations in the two models of line and point charges. It was observed that the negatively charged pen attracted the U-tape in my hand, while the two U-tapes repelled each other. One was placed off on a table, and then the other was ripped quickly off. Shown here is the computational model that was used for this experiment, with code shown on the left and the corresponding results on the right. It was to have been assumed that the tapes were held directly over one another, and thus the magnitude of the gravitational force and electric force would be equal, roughly 1.94 times 10 to the negative third. Charge of the tape was found to be 1.11 times 10 to the negative 8. Shown again is code on the left. Now is a composite of point charges instead of a single point charge. For the suspended piece of tape to float, the net force must once again be equal to 0, entailing the magnitude of the gravitational and electric forces should equal one another. Using guess and check, it was determined that the estimated net charge would be about 2.5 times 10 to the negative 8 coulombs. There were many different types of error present in this experiment, and the differences between the data and model predictions may be attributed to some of the potential sources described here. Leading the electrons to leave the negatively charged tape or accumulate on the positively charged tape was one major factor, likely originating from improper handling of the tape and the humidity in the environment. Now, addressing the what if and why of the lab's experiment. Due to their respective field lines in accordance with Gauss's law, the line charge has a greater charge value and more closely reflects the true nature and morphology of the tape. For the what if question, if the signs of the proton and electron were reversed, then the electric fields would swap directions, and instead of pointing inward for the negative charge, electric field would point outwards due to its field lines. However, given that the like charges repel, the observations from this lab should not alter. And then comparing the estimated value of the charge between the data in the first code and the second code, to reiterate, the two computational values for Q would be different, and the value produced by the point charge model was lower, which was observed, and farther from the real value. In short, these data demonstrated that greater accuracy is approached when the models incorporated more closely resemble the physical experiment, and this divergence can be accounted for in the differences between the theoretical simplification as well as the real-world conditions. However, they can still be useful tools for predicting the behavior of charges when some variables are to be solved for. And shown here again are the two main results of the lab produced using GlowScript. Being on the left are the point charges, and then on the right is the blue arrow showing electric force going up and the gravitational force in the yellow vector. The top tape is red and the bottom tape is blue. Thank you. Thank you for watching.